Hello students, in this video lecture, we will learn about the implementation of K-means clustering technique. So you all know that till now we have seen about the supervised learning technique. So in this video, we will learn about the unsupervised learning technique, that is K-means. So K-means can also be called as centroid-based clustering technique, where the user calculates the distance between the data point and the centroid. And if the data point is closer to one particular cluster, then the object is moved to that particular cluster. Okay, so and this process iterates until the objects within a particular cluster are similar to each other and dissimilar to the objects of other cluster. So here we have the information about the customer ID and the gender, age, and the annual income, and the spending score of the customers, the different people who visit the mall. So based on this given features, we are going to group the objects that is quite similar to each other. All those customers who have their similar income and who have their similar spending score. So for that, we are going to import the libraries that is needed for the implementation, such as the NumPy library and the Matplot library and the Pandas library to deal with the data frame. Okay, and then we have the machine learning library, sklearn. From sklearn, we need to import k-means. Okay, so because this is the built-in function which is available within this machine learning library, that is sklearn. And after that, to evaluate the performance, we have this Silhouette score and Davis-Bounden score. Like how for the binary like classification, we have the accuracy. Like for the clustering, we have this type of measure. So we need to import the libraries that is needed for the implementation of this K-mean clustering algorithm. And after that, we need to import the data set. So the data set has already been imported using read underscore CSV function. We need to read the input data set. So here we see that it is being stored temporarily in the data set object. So now what we are going to do is like, what are all the features that we are trying to consider? Okay, so we are not going to consider all the feature, okay, based upon the information which is available 0, 1, 2, 3, and 4. Okay, so that is we are going to consider only the annual income and the spending score of the customer and all the rows of this data frame, that is called as colon, comma, and we are going to consider the column annual income and the spending score dot values. We'll be able to retrieve all the values of these two columns. And the next important measure is like WCSS. Okay, so this is a type of a mathematical measure that helps us to find what is the optimal number of clusters, because user only is giving this number of clusters that need to be formed, whether 2 clusters or 3 clusters. Okay, so if the user wants to know what is the optimal number of clusters, so we have this measure that is called as WCSS. So this helps us to measure the sum of the squared distance between each and every data point and the centroid of that particular cluster. Okay, and the centroid of that particular cluster. So this is called as the elbow method. Okay, so the WCSS, it is called as within cluster sum of squares. Okay, this is called as within cluster sum of squares. Okay, this takes the square distance between each point and the centroid of that particular cluster. And this method, it is called as an elbow method because it helps us to find what is the best number of clusters. So to find the best number of clusters, we are making use of the k-means library, which is available within scikit-learn, which is available within sklearn library. We are going to import that module, and we are going to like assume an empty list, because we initially assume that the score for WCSS is null. Okay, but for the different values, we need to calculate what is the total number of values. So we are going to do an iterative process. Okay, so there is a for loop. This for loop, it runs for the different number of clusters. Okay, so starting from the first index position till 10. Okay, so initially it will assume that k as 1, then k as 2, and this process continues by till keeping the value of k is equal to 10. Okay, so now we give this function that is k-means. And here this takes the different parameter, that is n underscore clusters. Okay, because n underscore cluster, it takes the value as I, because initially it has to consider k as 1, then k as 2, till k is equal to 10. And init, okay, so init is a function that helps us to initialize the centroid for the cluster. So random state, this assumes that the results are reproducible. Okay, so once it has assumed the total number of cluster and initial centroid, so then the very next step is to fit this k-means algorithm to X. Okay, so X is, you all know what is available, only the two important features. So you are going to fit this k-means algorithm to the data set X. So and then we assume that this function k-means dot inertia, this will return what is the WCSS value for the current value of the clustering. First k is equal to 1. What is the WCSS score? So once it is done, we are going to plot this value for range of 1, 11, and the title is elbow method. The X label, X will be the number of cluster. Is the first we will try k is equal to 1, and what is the value for WCSS. And then k is equal to 2, what is the value for WCSS. So you can see that this is a graphical representation. So for the different values of k, so initially when k is equal to 1, so what is the value for WCSS? It approx 2,80,000. Okay, and then for k is equal to 3, for k is equal to 4. Okay, and you can observe that this is you can observe a sharp point. Okay, and after which there is a bend and not much change in the value of WCSS. So the moment you can observe the structure as a kind of an elbow. So this is assumed to be as an optimal cluster. This is assumed to be as an optimal cluster. Okay, so k by k is equal to 5. Now we have identified what is the optimal cluster. Okay, and this the same we are able to see using a plotting. So the next is like your algorithm is ready, and we have fit that k-means algorithm to the X input data set. Now we are going to do this performance analysis for the different values of k. So we are going to initialize an empty list, and we are going to assume the value of the result to be as empty. And we are going to do the testing from k is equal to 2 till 10. Okay, so why we are going to consider k is equal to 2? So if you want to have a clustering, you need to have a minimum of 2 heterogeneous group, right? Okay, so at least between male and female, there should be some grouping. So we can't do a clustering where k is equal to 1. Okay, so here the k, it stands for the clustering group. Okay, so how many? So it starts a minimal of 2 till it goes till 10. Okay, and here also we pass on the number of clusters that need to be formed is right from 2 till 10. and we are going to by default implement a centroid-based clustering algorithm. Okay, and we are going to fit and we are going to give the prediction for the X given input. So once we see that once the cluster centers are computed, okay, so we need to predict the index. So which is going to be a very convenient method. So once everything is done, we have to do the performance evaluation. So performance evaluation, you have to give Silhouette's underscore score of X comma Y means. Okay, so this is what the prediction is all about. We need to do a plotting between the value of X and Y underscore K means. And then Davis underscore bounding score, and which is the plotting between X and the K means. So the results are calculated and the results are appended to the list, which you can observe. This is your performance evaluation by assuming the different values of K. So we assume initially at least K is equal to 2 and then K is equal to 3 and K is equal to 10. What is the value of Silhouette and Davis-Bouldin score? So once everything is done, okay, so like we can do evaluate the clusters. You can see that X of K means of 0, comma 0 and K means of 0, comma 1. So this will be the X coordinate and Y coordinate. Okay, so X coordinate and Y coordinate of the first feature. And then X coordinate and the Y coordinate for the second cluster. X coordinate and Y coordinate for the third cluster. X coordinate and Y coordinate for the fourth clusters. This is for visualization, right? Once every data point is clustered, you need to print what is the value for X and Y. And then this yellow color, it is the centroid, and which is given with the huge circle, which is represented with the bigger circle. And the same is given here, the code for plotting the cluster centroid is cluster underscore centers of colon, comma, 0, and then colon, comma, 1. Okay, so we see that what is the centroid that is formed, and the size of the pixel is 100. Okay, and they give an yellow color, and you can give the label as centroid. Okay, so this is how we do the implementation of the K-means clustering technique. This is how we do the implementation of K-means clustering technique. Thank you all.